Okay.
I forgot you did it last week too, Joe. Sorry.
I tried. No, I tried and I never was able to,
Oh, yeah.
remember. So
Okay.
my fingers are crossed.
Okay.
Let's see. Dun, 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 dun. Where's the quiz again? Are you guys on the quiz?
Yeah.
Okay.
There's only 12 questions this time.
Woohoo!
Yeah.
Yay. Okay. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Distribution of means from parent population. Is it normally distributed? Because that's what we went over.
N.
Normal was my first thought, but
What's n mean? Oh, wait.
N is like the
I have like everything else. I have the U and the X and the O thing. I know they have names.
yeah, no. Like if you open up the app, I think that I want to say that's like the variable. That's what changes. Yeah.
The what?
It's like the population, how many people are sampled.
Mm-hmm. So
okay.
It's right skewed. Okay, so it says, as the sample size n increases, the sample mean draws closer to the population mean.
So n would be the population. Okay. N equals 5.
The distribution of means.
What is the shape of the distribution?
See, yeah. See, this is what I mean. It's like, oh, okay, good.
You get it until you get to the quiz.
No, I don't.
Right.
Well, because we went over not normally distributed and then normally distributed. And so in normally distributed, regardless of the sample size, so n, the shape of the distribution of the sample means is normal.
Yeah, it would be normal, I think. Yeah, because isn't that...
But when it's not distributed, as the sample size n increases and becomes large, the distribution of sample means becomes approximate.
Wait, n is...
Huh.
Wait.
I'm going to say it's normal, but I don't know.
That was my first thought.
Yeah, it was normal.
Mm-hmm.
Okay.
Oh, yeah. As the sample size n increases, the sample mean draws closer to the population mean. Accuracy. Minus accuracy? What? I would say normal. That's what...
The only thing that throws me off
as
is...
it increases. But if n is the sample size, then is 5 a big enough sample size?
That's what I was thinking, because usually you want it to be like 30.
Right, that's what they said. 30.
But it's right skewed.
But it doesn't tell us. We didn't go over.
Is it skewed right? Is it the same?
I don't know.
What's the shape of the distribution of means histogram?
I don't know. I'm gonna keep it on normal. What do you think? I'll do normal. You could do skewed right. We'll see what we get.
One of us do one of each, and we'll see who's right.
And then we'll have to ask questions. What does this mean?
Was there anything on this homework that said anything about distribution of means? Because I don't recall seeing that.
Well, just if it's not normally distributed, and then if it is, that was the only thing that we went over. Now they might be bringing up past stuff. So regardless of the sample size, the shape of the distribution of the sample mean is normal.
Wait, where did you read that?
That is the definition of the shape under the distribution of sample means when the parent population is normally distributed. That was from the video.
Okay.
Okay.
Okay,
you
so
sticking with
normal.
I'm going to keep normal.
That's what my gut says.
Follow your gut.
Follow my gut.
Okay.
I took a test the other day, and my husband every time tells me, don't ever go back and change your answers. And I did it, and I was like, yeah, I would have got 4 more right. No.
Dang, 4? Yeah.
He tells me every time. I don't do good on multiple guess. Okay, so when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? Guys.
Oh, great. Here we go again.
Okay, we've got to figure this one out for sure. Okay, so distribution of means.
Maybe it has something like at least what you were saying, since the population size is only 5, maybe it would stay right skewed, and maybe if it's higher, then it would be normal. But how do you distinct the definitions of normally distributed or not? Because they don't tell us that. If that makes sense.
Because n is the population, right? So, oh my goodness.
I would say number 4 is normal for sure.
Yeah, but then it makes me wonder if number 3 is skewed right.
Have either of you done the homework quiz yet?
No.
No.
So I did.
Oh, did
you? Just because I have to work ahead this week because I'm not going to be here next week.
Yeah.
So there was 2 questions talking about the distribution of means and the skew, and both of them were normal.
Yeah.
I'm pretty sure.
I don't know.
I'd say let's just put normal and then
we'll know.
Yeah, and then we'll take it again if they're wrong.
Yeah. But then here's another one. When you are taking a sample size of N5, what is the shape of the distribution?
Normal.
Histogram.
This is our third normal. Hold on.
Oh no, here. When the parent population, hey, there you go, normally distributed. So then you're gonna go to your normally distributed, and it says, regardless of the sample size N, the shape of the distribution of the sample means is normal. So this one's normal.
Yeah.
So if it says right skewed, should we just say that it's right skewed?
I don't know. On question 3?
Yeah.
I don't know.
You know what? I'll say skewed right. We'll see who's right.
Yeah, I'll do that too. Go back and change it.
Okay, let's see.
Here we go. Another one of these questions. This is so funny.
Are you coming or no?
When you are taking a sample size of N, what is the shape of the distribution means around the parent population is normally distributed? Same thing, right? Normal.
Mm-hmm.
Per their definition, regardless of the sample size.
So I got, no, let's see.
You're going to love number 7.
Wait.
Oh my gosh.
Oh, check all of
check all of them.
Okay, so.
Data are drawn from the population. Are you going to go pick up the boys?
Yeah.
Why don't you just have her drop them off? She offered.
Well, she did offer, but I said I'll come pick them up.
Because
I didn't want to wait on her.
Okay. Data are drawn from the population that is normally distributed, and the sample size is small.
Well, you want me to come back and get you then?
No.
Okay, well, we need to go.
Okay. So while you guys are looking at that, I'm going to read the definition of a normally distributed.
Okay.
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 It says one, or not one, I put one. Shape is regardless of the sample size n, the shape of the distribution of the sample means is normal. In the
That's what I
center, if the mean of the population is mu, then the mean of the distribution of sample means is mu. That's not confusing.
Yeah,
Spread.
so mu is mu.
Spread. If the standard deviation of the population is that other one, what's that other sigma? Sigma? I don't know.
I don't
Then
know.
the standard deviation of the distribution of sample means is sigma squared your sample size. Okay, so this says, when would the distribution means be normally distributed? Data are drawn from population that is normally distributed. I guess it could be. Data are drawn from population.
So is it 1,
large.
2, and 4?
Yeah, because it wouldn't matter.
Is that what you'd say?
It doesn't matter the sample size. I would say it's all of them. Only because it's saying, when would the distribution of means be normally distributed? Well, the definition is regardless of the sample size, the shape of the distribution is normal. It's always normal.
So then would the questions 3 and 4
Be normal?
be normal?
Yeah, I thought we already did that. It's normal. Oh, 3, we did
No,
right schema.
3.
4 is normal. 5 is normal. 6 is normal. I don't know, guys. All I can do is
Everything's
guess.
normal.
Yeah. And we're wrong. I mean, seriously, at this point, all I can do is guess. I mean, and then
Yeah,
just
we
go
have
back
we have a second chance.
and figure it out after. Because yeah, I mean, I can only go off of what I understand and what notes I took and what, you know what I mean,
Mm-hmm.
off the videos.
Yeah.
Okay, maybe the next ones are about not normal. Which of the following is the
The
best
standard
explanation?
deviation is defined.
So
Can you do multiple? Oh, no. So if the
It's-
sample size is large, the shape of the distribution of sample means will be approximately normal.
I think it's the third one.
what number are you on?
Third.
Number 8.
Oh, 8, yeah. So as the sample size n increases and becomes large, the distribution of sample means becomes approximately normal. Are you crying? Would you say, Elise? You say it's the third one?
Yeah, but let me look at the definition again.
Yeah, he said you need to understand the difference between the central limit theorem and the law of large numbers.
Yeah, I'm not having. Yeah, I had it switched, so it would be.
I think maybe it's the last one.
That's what I was thinking, but I don't know.
Because as the sample size n increase and becomes large, the distribution of sample means becomes approximately normal.
Yeah, I think it's probably the last one then.
Yeah, I think so. Yeah, the last one. That's what I'm going to put. Okay, so
Okay. Holy cow. Okay, use the following to answer this question. What X may. Okay. Where's my pencil?
All right, so are we on number 9 now?
Mm-hmm.
So you.
Okay.
So I can't even say this. Mu? Is that what you
Is
call it?
mu? I don't know.
So it's
So number 9 would be 10.
10. It's 10 is equal to 6 divided by the square root of 36. Am I right to say that?
That would be for number 10.
Oh, that's number 10.
Yeah, you're
Oh,
right.
what does the mean?
Or 9 is 10. That's the mean.
Mm-hmm.
Oh, right. Okay, so then 10 is what I had just said.
It would be
Then what's the standard deviation?
standard
So then you have to do that formula. Or
Yeah.
no?
Am I right? 10 is equal to 6 divided by the square root of 36?
Gosh, my daughter's crying. I cannot focus. This is so annoying. Okay. So 16 days. So what is this? So the sample size is 36. So it's going to be this square root is 36, and then the standard deviation, and then 6, right? And then that's going to be that's 1.
I got 1 as well.
Okay. Where's Dad? I need to go pick up the boys.
Okay, okay, so did you do 10 is equal to 6 divided by the square root of 36?
I did,
Just
yeah. I did 6 divided by the square root of 36.
right. Mm-hmm.
Right, okay. Is it bad I don't know where to find that on my calculator?
No.
6
Well-
divided by, okay, guys, I'm showing you my calculator.
Oh, yeah, let me go back to the
You
camera.
probably can't even see it. It's probably all
Yeah.
blurry. How do I do the square root of 36?
Move it
Go
over just a little bit.
Go up.
Because this is the square root, right?
So, yes.
Oh yeah,
let me
right
see.
there.
So
Okay,
you push
so-
the second button. There should be a button that says second.
Oh,
And then
Wait,
you put the square root.
oh. Ha, okay.
And then type in
Yes,
36.
I got 1. Guys, I got 1.
Yay!
I love it. Okay.
Wait. Well, 1 is the square root, but don't you do 6 divided by 1?
Well,
Well,
no, it's 6
the
divided by
square root-
6.
the square root of 36 is 6. So that you divide
Oh.
6 by that, it would be 1.
Okay. So the square root of 36 is 6.
Uh-huh.
Uh-huh. And then 6
Oh.
divided by 6 is 1.
Okay, guys, I get it. And I now know where that second button is. It's been a long time, guys. Like,
Yeah.
Oh, I hear you.
Yes.
let me tell you, like 10, 12 years, something like that. I don't know, maybe more than that
Okay.
because I dropped out of math in high school. So let's see.
Dude, I can't believe I graduated high school with my math. I think that was back in the day.
Right?
They don't allow that anymore.
Yeah.
Okay.
Geometry was as high as I got.
Really? Oh, good for you.
Yeah, I didn't go higher than that in high school.
Yeah.
Uh,
Sadly, I don't even remember what I did.
I think I got to algebra, and that was the extent.
Yeah.
All right. Regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution of the sample?
Normal?
I'd say normal.
That's what I'm going to say. But I'm feeling like not everything can be normal, right?
I don't know.
It's a trick. It's a tricky test.
Yeah,
Wait, did you guys put skewed right on question 3? Or did we stay with normal?
Did. I put skewed right.
Yeah,
Okay.
I did skewed right.
Okay. If they're all normal, I'm going to laugh. Okay.
Yes,
What theorem would justify your response to law of large numbers, right?
Well, because that says the greater the amount of observations in our sample, the sample mean draws closer to the population mean.
So large numbers, right?
Mm-hmm. Watch it be the central limit theorem.
Yeah. Wait, but it says the central limit theorem states that if the sample size is large, the sample mean will be normal.
It'll be approximately normal, yeah. I don't know.
Oh, standard deviation. I think
I'm
it's
gonna
law of
say-
large numbers. Law of large numbers. I can't talk.
There was already a question about the central limit theorem, so I'm gonna say
Yeah.
Okay. No, I think it's
We're not even.
I'm pretty sure
We're
it's
just
large
using
numbers.
logic here. We're not even using like
Yeah.
skills of math. Oh, dang it. See, one of them. On number 7, there's one that's not right.
Oh, did you already
Which one?
submit?
I don't know. Oh, yeah, I did.
I didn't, but I think the one I would say is wrong.
Is 3?
The third one down. Yeah.
Number 3?
Yeah, I think so.
Okay.
Wait, let me submit it. Let's see.
Well, the last one's wrong. It is central limit theorem.
Oh, really?
Yeah, that's okay.
Oh, no.
So number 3, do you have like a like I want to understand that. See, this is why I'm glad we're gonna meet again, because
Wait, number 3 was wrong too?
No. I mean question 7, the third one.
Okay,
Of
hold
why.
on. Okay, yeah. So
I think number 4 is normal.
Number 4 is normal.
You put normal?
Oh yeah.
Okay.
No, we got all the other ones right.
yeah, so 7, it's the third one down that is wrong.
Mm. Okay. Dare I
I have
take
to
it
read
again?
that. I have to read that last one again. Central limit theorem, because
Well, that's because they say it's close. Like, yeah, to understand it is important, and they're similar.
they're so similar. I know they said that that's like the most common thing to get mixed up, right?
Hmm.
Mm-hmm.
Yeah, and I'm mixed up.
All right.
I felt like I had it last night, and
I know. Well,
Oh,
now it's just like mixed.
mm. I know. I feel like I need to better understand this though, because
yeah, I do too.
to be able to do well, to keep progressing, like it's. I miss being in a class, guys, where I just go for an hour and have someone
I know.
explain it to me, and so nice.
I know.
Okay.
I like that we have these groups though, because I think I'd be
Oh
even
yeah,
more
no,
lost
I would be
without it.
like, yeah,
For sure.
yeah. It takes nothing away from our group. I'm just saying in general, like,
Right.
this would be a lot less time consuming, I feel like.
Yeah, I agree.
All right, well,
I'm still trying to grasp the difference between
yeah.
normal distribution or
The law of
large numbers to the central limit theorem.
Because they both start out as the sample size increases, and then it becomes different. The central limit.
The sample size increases, the standard deviation the sample mean will get smaller. So one, the standard deviation gets smaller, and the other one, wait, they both do.
Well, as the sample size
Wait.
increases, the sample mean draws closer to the population mean. They said the law of large numbers is more for accuracy. The standard deviation will get smaller as it gets closer to the mean. I don't know.
Let's see. So for the homework assignment, the central limit theorem tells us that the distribution of all possible sample means will have a normal distribution if the sample size we chose is large. And the law of large numbers, tells us that if we have a simple random sample, the sample mean will be close to the mean if the sample size is large.
Yeah.
Okay, so you guys get this? You guys understand it, right?
So with the law of large numbers, you want a bigger sample size. It's kind of like rolling the dice to like show a pattern.
Right.
The more data you collect, the closer it'll get to the mean.
Right. Okay.
Yeah.
But then how do you wrap your head around the central limit theorem then? Because
Yeah, that's the one I can't.
It becomes large. The distribution of sample means becomes approximately normal.
I don't know.
It's okay.
I don't know.
It's okay. Too, we're gonna have our TA with us soon.
This is true. Well,
Is she coming
on
with us?
Friday, she's doing that review, that test review, right?
Oh, yeah, I'm gonna do that. Yeah.
That too.
Mm-hmm. So.
Yeah, the problem with that is I'm taking the test Friday, I think.
Oh, are
Uh-oh.
you really?
Oh, no.
Yeah. Maybe I'll try to take it Saturday instead.
Yeah.
Or see if the TA can meet with you.
Ooh, good idea.
That's a good idea.
That
We'll
might
see.
help.
No, lots of help going on this semester.
Oh, for sure.
Yeah.
That's for sure.
So, all right. Well, I'm glad this didn't
Alrighty.
take like forever, but
Right.
yeah.
Thursday might
Are
be
we
different,
supposed to be meeting for a certain amount of time, or does it matter?
No.
I don't think it matters.
This makes up for last week then.
Over a 2-hour meeting, yes.
Yes. We don't need to have meetings the rest of the semester, guys.
Yeah, there should be a half hour.
Yes, exactly. Yeah.
No, that's good. All right. Well, thanks, guys.
Alrighty.
We'll see you
Okay,
Thursday.
thank you guys.
Okay,
All right,
bye.
we'll see ya.
Bye.
Bye.